Hello, welcome to unsupervised learning, which basically means clustering. So, what do I mean by clustering is that when you do not give your machine learning algorithms a label, it forms certain clusters, which by which I mean group. It groups your data, and on the basis of that group, it identifies where your data has grouped together, and with respect to that group, it gives some labels all by itself. So that's what unsupervised learning means. Means there is no human supervision, very little human supervision. So if we look at the formal definition of unsupervised learning, unsupervised learning is a type of machine learning that looks for previously undetected patterns in a data set with no pre-existing labels and with minimum human supervision. So that's why it's called unsupervised learning. So as we know what unsupervised learning is, let's see how we can use this data set, which is a labeled data set, and how we can use this data set to tackle our problem and to do unsupervised learning. And since this is a labeled data set, what we can do is we'll ignore the label. We'll not take this target key or this target names. We will not use it for our machine learning algorithm. We'll just only use the feature values. So if we want to look at the feature values, see we have four features, and they are sepal length, sepal width, petal length, and petal width. And these are the four feature corresponding features, and we will not provide any labels for this algorithm. And in unsupervised learning, there are many algorithms that you can use. Some of them are k-means, then mean shift, then you have spectral clustering, hierarchical clustering, and many more. So we'll look at k-means clustering today. What k-mean does is basically, if you can see some clusters here, right? You can see your data can be grouped together, but your computer cannot see it, do not have any eyes. But what it can do is it can do some mathematical calculation, and on the basis of that it can form some clusters. So here you can see the violet color cluster can be grouped as class 0, and this yellow color cluster can be grouped as class 1, and so on and so forth. So how it does this is basically, I won't go into details, but to give you some idea about this algorithm, what it does is basically, for example, in the very first iteration, it randomly selects 4 points. For example, in this data, we want our algorithm to form 4 clusters from this data. So if we want it to form 4 clusters, so it randomly selects any 4 points from the sa from the sample. And for example, this yellow color sample is from class 0, and this pink color one is class 1, and this blue color is, this light blue is class 2, and for example this orange color here is class 3. So after doing that, it calculates the nearest sample point from this, from the sample point which are already calculated with a class, which are already labeled. So for example, from this yellow point, it looks at the its nearest sample using Euclidean distance. So basically, if you want to calculate, let's look at this let's look with respect to this yellow point. So here, from this yellow point, you can see that this point is nearest. So based on the Euclidean distance, it will label it as yellow. And after doing that, it calculates the mean of these two clusters. So it calculates the mean of these two clusters, and on the basis of the mean, it again takes a sample and labels it according to the Euclidean distance. Same goes for the blue color one, and same goes for the yellow color and the pink color one. And on the basis of that, it continuously does the iteration, and a new cluster is formed and a new mean is calculated. So for example, after and here you can see, since you can see here majority of the points will be yellow, and since majority of the point will be yellow, this blue color point will also be turned as yellow, and you can have the mean of yellow here, and this all the points will be classified as yellow points. And as a result, you will have the blue cluster here, and same goes for this orange color, and same goes for this pink color class. So this is how the clusters are formed. So your algorithm keeps on reclustering, and it does not stop until the clustering does not change, until the mean does not change. So it keeps on clustering until the mean of all these classes does not change. Until the clustering does not keeps on changing, the iteration keeps on running. So that's what k-means does. So let's see the implementation of this k-means algorithm. So here you can see there are three classes of data. In order to see that, what you can do is you can tell your algorithm like how many clusters you want to form. But as we have three types of plant here, so we will obviously want three clusters. So that's the basic idea behind using 3 as the number of clusters here. So from sklearn.cluster you can import k-means class, and with that k-means class you have to pass the number of clusters that you want, and this random state basically means that all the randomly picked value will be same over every iteration that you do. So after doing that, you have to basically fit only the X features. So we have been seeing all this time in supervised learning that we fit the X data and the Y data as well. But here we are only fitting the Irish data dot data. So Irish data dot data gives all the feature values of our samples. So it gives all the feature values, and using those feature values we can fit it. So if you want to take a look at what this Irish.data is, Irish data, see, it contains all the feature values. So I don't want to see all of them. Let's see only. See here you can see it contains all the feature value, and you can also see the shape of this. See how many. So here you can see we have 4 columns and 150 samples, and using that we fit it, and after fitting it we'll see what's the center of the clusters. What do I mean by the center? Your mean is calculated based on the center, so the clusters have a center in them. So this center is denoted by this kms dot. This is a variable that your kms object has, so you can just print it out. So this is a class variable that your object has, and you can print it out. So here you can see we have a weird shape matrix. You might ask, why would the center value be like this in a matrix form? So what I want to say is that it's because it's a four-dimensional space. So since it's a four-dimensional space, we cannot visualize it. So the center should be based on 4 points. So for example, if this is a four-dimensional space, then we have this as y, this x, this z, and this one as k. So in the four-dimensional space, so we have four-dimensional space because we have four features. So in the four-dimensional space, there is only one point. This denotes only one point. One point. So the that one point has four values. So basically, in the four-dimensional space, this is just a point. And since we have three clusters, for three clusters we have three rows. So there are three centers only. So that's the basic idea behind this centers it formed. So based on the center, it drew the boundary. So let's evaluate our model. Let's see the predictions. And since we have the true labels of all the 150 samples, we'll cross check with it, like to see how well our k-means cluster has worked. So to see that, to see the performance of the k-means cluster, I have created a small function here. I've created this function to so that the labels that this k-means cluster provides do match with the true value. For example, since this k-means cluster randomly provides some labels to your data, you can print out all the predictions. So let's look at the 150 predictions. So these are the predictions that we have for our three classes. And on the other hand, let's look at our true label that we have in Irish data dot target. So let's see. So here you can gain some intuition that the zeros are provided a label as 1, and all the zeros are given a label of 1, and on the other hand, 2's are labeled as 2 as well. So that's why I've created a function here. Basically, this function, what it does is it transforms all these predictions, which are wherever it's labeled as 1, it changes it to 0, and wherever it's labeled as 0, it changes it to 1 to match with the true values, and wherever it's 2, it remains as it is. So that's what this transform function does. So let's run it, and after running it, you can see the prediction of the k-means algorithm. You can see that it is almost similar to this true label, and let's see what is the accuracy we have now. Since we already printed the actual labels, let's see what is the accuracy we have now. Let's evaluate our model. Let's see what is the performance of. So here you can see we have a performance of 89 90%, close to 90% accuracy using k-means algorithm. What you can do is you can also, from pandas.crosstab, you can also use this function and check where it has misclassified. So here you can see it has correctly classified all the zeros, but in the case of 1 and 2's, it has the k-means classifier has mislabeled some of the data. So that's it from the unsupervised learning part, and